Now that we have good understanding of how this DOP.NET work, how we can dive inside the DOP.NET and create our own simulation network, we also have the smoke solver available right inside of this SOAP network. And if you type in here, let's say Pyro Solver, let me see, here you can see if you type smoke, we do not have this smoke solver, but if you type Pyro in here, and here you can see at the very top we have the Pyro Solver. Let's add this, and here you can see we have that. And the Pyro Solver, you can use this Pyro Solver to create your smoke simulation, your fire or explosion. You can do all of your things with the Pyro Solver as well. And in here you can see we have the simulation type. We are using the Spot Solver, and we also have our regular dense solver, and we also have the minimal OpenCL. Minimal OpenCL is a solver that uses your GPU, your graphics card, to run on your GPU to accelerate your simulation. And this Pyro Solver, this SOAP level solver, it's actually not another solver. It's actually a digital asset. And here you can see we have this lock button. This lock button indicates that it's actually a digital asset, which means we can double click on this and we can dive inside. And if I double click, and here you can see we are inside of the DOPS, we are in the dynamics. And when we double click or this node, here you can see we have gone into several level deep. So we were in the Pyro Solver and we are in the DOP.NET, and inside of the DOP.NET we have a forces node, and we are right now in the forces node. But it's actually an DOP context, the dynamic context. I can go back, and to actually view my nodes and all of these settings, I can just right click, and in here let's enable this allow editing of contents. Let's enable this, and if I when you click this, here you can see our lock has been opened, which means that we can now dive inside and edit this Pyro Solver. So let's dive inside, and in here you can see we are right now inside of the SOAPs. We are in the geometry level, and there we have quite a lot of these nodes, and they are just there to set up your parameter and simulation. And inside we have this DOP.NET. If I zoom in, and here as you can see we have the DOP.NET, so I can dive inside the DOP.NET, and now we are in the dynamic context. And now if I zoom in, and here as you can see we are using the Pyro Solver, and right now we are using the sparse Pyro Solver. And we know that this very first is the object. If I were to trace this, we should see our object, and here as you can see we have this smoke object. We are using the smoke object sparse variant, and this will store all of your information. And it's actually an DOP context, but with all of these pre-configured node and all of these settings. This Pyro Solver, here you can see we have some options, and their color has been turned into blue, and these are indicating that all of these parameter has been promoted into our this level. Let me go back onto our this Pyro Solver. So we have all of these settings. So these are the settings that has been promoted from our this original Pyro Solver, and we have some other simulation node, we have some forces, and all of these things has been pre-configured for us to easier to work with, which means we actually do not have to create our own this network every time we want to create our smoke simulation. So we can just go into the SOAP level, and in here we can create a Pyro Solver. I can add Pyro Solver, and I can just start playing around with my voxel size. I can go into my sources to import my sourcing, and inside of field we have the shape tab, all of the forces built in here, which means I do not need to waste my time every time I want to create smoke simulation. I can go into the DOP.NET, add a smoke object, add the source and all of these forces. We have all of these things pre-configured with this Pyro Solver. It's actually a same DOP.NET. It's nothing new. That is the point that I want to make. Let me remove this Pyro Solver and I'm going to use this one. And now let's see how we can create our this simulation with using this SOP level Pyro Solver. And for that, I can just connect this source. I can view the Pyro Solver node, and in here as you can see, this source has been imported, or this source has been working with the Pyro Solver. I can hit rewind and hit play, and here as you can see, we have the same effect. Our source has been imported, and right now we are keep importing our source every frame. That is why this density volume is getting accumulated. We are getting thicker and thicker our smoke. So let's make this force move, which means I can go into the Pyro Solver, and here we have all of these settings. First we have the voxel size to control the resolution, and the next tab is the bound tab. Bound tab is used for this domain size, and I can limit my max size, and I will first let me make this default, and I will explain to you later what this limit maximum size is. And the next tab is for the collision, if you want to import the collision in here. And when we are working with collision, this second input here, as you can see, that is for the collision. And if you have collision geometry in here that you want to collide with our smoke simulation, you can control your collision setting in here. And onto the sourcing, here we have the volume source, and in here we are importing our sources. So all of these geometry that has been connected onto this input, okay, that is the sourcing input. And in here we are importing our density volume into this corresponding density field of the top net. And same way we are importing all of our fields, but right now we only have this one volume. Okay, so that is the sourcing tab. And onto the fields tab, here we can control the dissipation, and to add the forces we have this shape node. Let's dive inside, and in here we can enable all of these forces. I can enable the wind force, and I can also collapse its menu. And here as you can see, we have the wind speed and the wind direction, and right now we are adding the wind in the X direction. Let's see how this X direction wind looks like. Let me hit rewind and let's hit play, and here as you can see, our smoke is moving in the X axis. Right now its speed is slow. Let's increase the wind speed. I'm going to just play around with this slider and hit play again, and here as you can see, our smoke is moving along the X axis. And I can enable some other forces, and let me enable the turbulence force in here. So let's enable this, and to actually view the effect, I'm going to just really exaggerate the effect by increasing its value, and let's hit play again. And right now we have some movement, but it's not quite a lot. So maybe let's continue increasing this value to a higher value so that we can really see the effect. Let's hit play again, and it's still not working. Let me collapse this menu, and that is because this turbulence has been applying onto this temperature field. But right now we are working with density. So in here, let's pick our density field. I can either type my field or I can just pick from here. So let's click on it. So now we are applying our turbulence onto our density field. Let's hit rewind and hit play again, and now I can clearly see my turbulence force acting on this smoke simulation, and it's starting to look like as if we have this dust storm. I can go into the next tab. Let's go into the next tab, that is the look tab. And onto the look, here we can adjust the look for our smoke simulation. I can adjust the density if I want to create a thicker, and this look is actually applying the material as well. In here we are getting the feedback onto our viewport, but we are also applying the material as well, which means if you were to render this, you will get these same values. And we will take a look at these rendering later, but in here let's quickly go over through all of the settings of this Pyro Solver to controlling the simulation. That is the density, and I can adjust the play around with the smoke color. Maybe let's change its smoke color to a brown because it's a dust storm. I'm going to create this trusty color. Let's hit rewind and play, and here we have our dust storm looking like simulation. And down here we have the option to adjust with the fire, but right now we are not creating the fire, that is why this parameter has no effect. And in here we can play around with the color of our fire. And in the next tab, let's go into the advanced tab. Onto the advanced, we have some solver level advanced setting. We can play around with this our sparse solve and all of these advanced setting. And the next we have the output. This output is the top import field node, and this top import field node. Here you can see we are importing these field. So this Pyro Solver, this output is actually importing these fields back into SOPs, and that is why we have this feedback into our SOPs, because we are in the geometry, we are in the SOPs, and I can still see my smoke simulation. That is because this solver is actually importing all of our fields back in here as well. And we also have some post-processing option. I can in here convert this into VDB, because right now if I were to middle mouse button onto my Pyro Solver, and here as you can see we have quite a long list of the attributes. We have all of these detailed attributes, these simulation attributes, and down here we have some volumes. So we are working with 6 grid volumes, which mean the Houdini native volumes, and we have all of these volumes. And to actually later on, when we are going to create the smoke simulation, we need to store our caches into disk for rendering, because right now we are actually storing our caches inside of our RAM. Here you can see we are storing in RAM. And when we are going to create a complex smoke simulation or fire simulation, and we have the voxel size set to lower value, which means we are going to create a high-res simulation, your system RAM may not be enough to handle all of the high-res simulation data. That is why later we need to add a file cache node. If I were to create a file cache node, so let's add this, and that is the file cache node in here. By using this file cache, we can write our simulation data onto our hard drive, because this high-res simulation will turn into high gigabyte data. We must need to store this onto our hard drive. And onto the output, we have the option to convert this to VDB. So which means before we can write out our simulation data, we can convert this to VDB, and that will convert your simulation into VDB, and we will take advantages of using the sparsity, because VDBs are sparse. And now if I were to middle mouse button, and here as you can see, now we have 4 VDB volumes. So now we are not working with Houdini native volumes, but we have these VDB volumes. So they will be much easier, and they will have a much lower cache size to write onto your hard drive. Always convert this into VDB, and we can also use the 16-bit float. This 16-bit float means that we are compressing our volume even more by just lowering down the precision. By default, it uses the 32-bit float, which is a high precision value. For rendering, we do not need the 32-bit float. We can convert this back into 16-bit, and that will even make your file cache size lower. And make sure to, whenever you're going to write, make sure to check both of these options, convert to VDB and use the 16-bit float. That is the basics of this Pyro Solver that is available inside of the SOP. And right now we are using the forces that are available into this shape tab. We have the wind, we have all of these forces, but here as you can see, there are not all of the forces. For example, if I want to create the gas access force, here as you can see, we do not have the gas access force. So what if I want to create additional forces? beside all of these forces. And I can create them by, if you dive inside the Pyro Solver node, and if I dive inside, and here as you can see we are in the top context, and in here we have these multiple outputs. Here we have the output for the forces. Here as you can see we have the force output, which mean I can create additional forces. For example, if I want to create the gas access force, because we know that this force is not available at the top level, so let's add a gas access force. I just need to connect this in here, and now this force will work. To actually view this work in action, let me go back onto my this geometry level. In here, I'm going to just disable all of the forces that are working right now. I'm not using any forces that are available in here, which means if I can go back and hit play, and here you can see there are no forces, but I can see the same effect, and this movement is coming from our gas access force. So now I can dive inside the Pyro Solver. I can select my gas access force and hover over to the viewport and press enter, and we have the same manipulator. And I can rotate this cylindrical shape, and maybe let's hit play. I can move this down. I can increase this cylindrical size. Maybe let's increase this size in here, and also let's play around with the parameter gas access force. And in here I want to increase the orbital force, this rotation force. So let's go into the orbit force, and onto the strength. I'm going to really exaggerate the strength and hit play. Maybe let's increase this even further, and I can interactively change this force value, and let's increase its global strength as well. And right now we are using the 1. This global strength will act as a multiplier. Okay, so we have all of these strength, and all of these strength will going to be multiplied by this global strength. So I can increase its multiplier to even increase the force effect. And let's also apply this as an F force, because right now we are adding the directional drag. Let's apply this as an F force so that we have much higher effect of this force. And let's hit play again, and now we can see the same effect. And I can continue adding more forces into my drop net. And right now we are using this one gas access force. So in here, let's say if I were to add another force, let's say we have this gas turbulence force. If I enable this, and here as you can see we have this turbulence, and if I were to add, let's say, another turbulence force to layer multiple noises to break up my simulation, I can do so by diving inside. And in here I can add another turbulence force by typing the gas and now the force name. And I want to add the turbulence force, so let's add this. And now to actually connect both of them, we need to merge both of these forces. So let's add an merge node and merge this gas access force as well as this gas turbulence. And in here I can play around with the setting. I can adjust the scale. And now let's go back and hit play. And now here as you can see we have the access force, and we are layering down the noise on top of this access force to create an interesting smoke simulation. I can go back, I can enable another layer this force, and turbulence is actually available. We have enabled in here as well. So we are mixing both of these noises. I can enable my wind force in here, and let's hit play. And that is the basics of how you can create your smoke simulation. We are going to layer down multiple of these forces to achieve our desired look. And I can dive inside the Pyro Solver, and I can continue adding more and more forces. Let's say this time add another gas disturb node to disturb our field. So let's type gas disturb, and I just need to connect this into merge. And in here gas disturb, I can adjust the strength, and we need to go back at the very first frame. I can adjust the strength value, and I can go back and let's view and we should see some of the smaller breakups. We are also disturbing our smoke simulation. Let me stop this. That is the basics of the Pyro solver. Let me remove this file cache. We will cache our simulation later, but that is the method of how you can create the Pyro solver. We know that how this Pyro solver, this topnet work, because we have created our own topnet, and we have the Pyro solver, the same functionality but with some higher level. All of these option has been promoted into our this top level, higher level to faster create our smoke simulation.